Under still under application of inductive effects, under strength of bases. We have sir?
I'm listening to you.
We have ammonia, methylamine, dimethyl. I want to ask under trimethyl amine. You said we have 4.20. Then in the video you said it decreases. Like I don't understand that part.
Give me 1 minute, please. I will come back to you.
Okay, sir.
Wow. No. All right, Munira, your question again.
Okay, sir.
Yes.
I said under strength of bases.
Yes.
So I said under trimethyl amine or amine, we have 4.20.
Yes.
Then it said it decreases. Like
yes.
I don't understand that part, the whole part of that strength of bases.
What we said is that we are measuring the strength of bases based on the PKB. As you can see now, I hope you can see it.
Yes, sir.
So if you recall, we said for acids, we use pKa as a measurement. And we said that the lower the pKa, the stronger the acid. The same thing also go for bases. The lower the pKb, the stronger the base. Are you getting it?
Yes, sir.
So if you look at the base we have and their pKb values, you notice that ammonia, the first one, has a pKb of 4.75. Okay?
Yes, sir.
Methylamine has a pKb of 3.34, meaning that from 4.75 to 3.34, there is a reduction. And the base strength increases. The lower the pKb, the stronger the base. Okay? Now,
yes, sir.
Dimethylamine, there is also a decrease in the pKb, meaning the strength of base increases. That's what I tried to say. The lower the pKb, the stronger the base. Do you get the point now?
Yes, sir.
Now, what do you say happened to trimethylamine?
And sir, we have 4.20 there.
Yes.
Like what I'm trying to say is that 4.20 is higher than 3.29, and you said it decreases like from 4.75 to 3.34. Then why is
you get the point again? The lower the pKb, the stronger the base. If you have a higher pKb, the base is weak. But if you have a low pKb, the base is strong.
All right, sir.
That's the point. So from 3.29, which is lower than 4.20, 3.29, the one that has 3.29, which is dimethylamine, is a stronger base than trimethylamine, which has 4.20. Get the point?
Yes, sir.
That is it.
Thank you, sir.
What I expect you to ask is that dimethylamine has 2 methyl group, while trimethylamine has 3 methyl group, because what is responsible for the strength is the presence of the methyl group. In methylamine, you have only one methyl, and it's stronger than ammonia, which has none. Do you get the point?
Yes, sir.
Then in dimethylamine, it has 2 methyl. Because of the 2 methyl, it's a stronger base than methylamine. Do you get this?
Yes, sir.
Now, trimethylamine, it has 3 methyl. We expect it to have, to be stronger than the one that has 2. Is that not?
Yes.
But it is weaker. So what is responsible for that? That's what I expect you to ask. I did explain the reason in the lesson, but let me explain it again. It is because we expect it to be stronger base because of the 3 methyl group that will be donating electron to the nitrogen atom. But because another factor is playing a role, is operating in trimethylamine, that factor overshadows inductive effect. That is why it is a weaker base. And what factor is that? It is the steric effect. Steric. There is an effect also playing a role here known as steric effect. It is that steric effect that lower the basicity of trimethylamine. And what is steric effect? The steric effect is preventing the lone pair of electron on nitrogen to be available for bonding to a proton. And that is why it is a weaker base. Do you get the point, please?
Yes, sir.
Okay.
Please come again, sir.
I said steric effect is...
Now, from where you explain why the trimethylamine that has 3 methyl group is not as strong as the one that has just 2 methyl group. That's the part I'm missing.
I said we expect trimethylamine, which has 3 methyl group, to be a stronger base than dimethylamine, which has just 2 methyl group. Because it is the presence of the methyl that increases the strength of the basis of this molecule. The one that has 1, sorry, let me start from the ammonia. Ammonia has no methyl. It has hydrogen. Okay? It is a weaker base than methylamine. Methylamine, instead of hydrogen, it has methyl. Methyl donates more electron than hydrogen. That is why methylamine is a stronger base than ammonia. Are you following me?
Yes, sir.
Now, dimethylamine has 2 methyl group that is donating electron to the nitrogen atom. Okay, it has 2 methyl instead of 1 that methylamine has. Because of the 2 methyl group present in methylamine, it is a stronger base than methylamine. Methylamine has 1, dimethylamine has 2. So dimethylamine is a stronger base than methylamine, which has just 1 methyl group. Okay? Now, trimethylamine has 3 methyl group. We expect trimethylamine to be a stronger base than dimethylamine because trimethylamine has 3 methyl group that will be donating electrons through inductive effect instead of 2 that are present in dimethylamine. You know, when you have 3, you have more donation than the one you have that has 2. But the reverse is the case. Instead of trimethylamine to be a stronger base, it's rather a weaker base. We now said, what is responsible for this observation? What is responsible is not far-fetched. It is because another factor is operating in trimethylamine. Okay, instead of inductive effect, another factor is operating, and that factor is steric effect. And because steric effect, it has more influence than inductive effect. It lowers the strength of the base of trimethylamine. And that is why trimethylamine is weaker than dimethylamine. Is that understood, please?
Yes, sir.
Any other question? Any other question? Are you sure everybody has listened to the lesson? Because you are not asking me question now. And I have part of questions for you. You are going to answer. Okay?
Like I've said yesterday, I still do not understand that lesson very well. So I think when I still continue to listen, so I'll get whatever I'm missing. So that's why I'm not asking the question.
So, I mean, nobody has asked question for me. $11, $12, $13. Okay. Somebody is sending a message on the WhatsApp. Do you know what the issue is? Khadija said she tried everything, she couldn't do what? I don't know how we are going to solve this problem of not being able to join the class. And if people are not, I mean, how do you go about it? This candidate, has she joined the class? I mean, has she participated before?
Thank you.
Let's see.
Sir.
Khadija DJ.
Yes, sir.
Has she participated in our class before? Because I can see a message that she couldn't join the class now.
I think this is our first time.
So I don't know what we are going to do for this in this case.
Sister Rihanna, I thought you explained to them in the group how to do that.
Shukra Ahmed, can you unmute your microphone and play your camera? Put your camera on. Is Shukra Ahmed in the class? Okay. All right. There's been this request that we should go through the lesson again. Or let me do this. Should I play the video for you to listen to it again now? Then if you have questions for me, you can ask. Can we do that?
Let's try that thing.
Let's what?
Let's try that.
Okay. I will try to. Okay. I think this is the. Okay. I will share the lecture, the lecture something to you now. So that you can listen to it, watch it, and I hope you can see it. Just a moment, I will try to get the video for you so that you can listen to it. Okay. Now the lesson is about to start. Are we set for it?
Yes, sir.
Now we can now start listening to it. Somebody is disturbing. Who is that?
What?
This is what we do. Now we can listen to the.
We can't hear anything, sir.
Can you hear the lecture now?
No, sir.
I think you should try to mute your microphone so that you'll be able to listen to the lecture seamlessly. Right. Is it everybody that can't hear anything?
I can't hear, sir.
Yes, sir, I cannot hear, and my microphone has been muted since.
Okay, hold on. I wouldn't know why you can't hear. I have increased the volume to 100%. So you should be able. Please let everybody mute their microphone now. So I'll start playing it again. Okay. If you can't hear again, just send me a message.
Excuse me, sir. I think we need to break this silence. We are not hearing anything. We just think maybe it will peak. That's why all of us are not hearing. We have dropped messages in the chat room.
Since you say you can't hear anything now, I've tried to play the same video on my system, but it's not coming up. The one I'm showing you is from the web, from YouTube. So I don't know why you can't hear it. In any case, what should we do now, since you can't hear the video? Hello?
Sir, maybe you should just re-explain instead of the videos. You can't hear anything.
It's okay. If doubt will solve the problem. Let me then go through the slide. Okay, can we all see the slide?
Yes, sir.
Yes, sir.
You can all see the slide.
Yes,
now
sir.
we are talking about factors that affect availability of electrons. Okay, and one of such, let me start. One of such factors is inductive effect. Okay. Somebody is trying to say something. Right? Can we continue?
Yes, sir.
Yes, sir.
One of the factors that affect availability of electrons is inductive effects. And this is illustrated in this diagram. You have it here. Inductive effect is when you have polarization of bond. Okay. For instance, in this carbon chain, we have an electronegative atom. that is bonded at the terminal end of the chain. The electronegative atom will be pulling the bonding electron between it and this carbon toward itself. The effect of the pull will be transferred along the chain up to at most the fourth carbon atom. It is this effect that is referred to as inductive effect. Now, in the case of electronegative atom, it will be pulling electron toward itself. Okay? In that case, you say we have negative inductive effect. But if you have a less electronegative atom, an atom that is less electronegative than carbon, rather than pull electron toward itself, it will be donating electron towards the carbon chain. If you have such situation in which an atom is pushing electron towards the carbon chain, we said we have positive inductive effect. Another fact you need to know is that when you have polarization between a bond, one of the atoms will be partially negative. The one that is less electronegative will be partially positive. Okay? Like I said, that the effect will be felt along the chain, but the effect will not be as strong in the second carbon as it is in the first carbon. It will diminish until you get to the last carbon where the effect terminates. And normally, inductive effect terminates at either the third carbon atom or the fourth carbon atom. After the fourth carbon atom, the effect is negligible. It's not effect again. That is inductive effect. Do you understand that? Okay. Generally, groups or any atom that is more electronegative than hydrogen, we have negative inductive effect. And those groups that are less electronegative than hydrogen will constitute positive inductive effect. And examples are given in this chart here. Okay, I will say generally the alkyl groups, they're always electron releasing, electron donating groups. So they will operate positive inductive effect. Now, there are other factors that are similar to inductive effect, but they are not inductive effect. One of them is field effects. Field effect operates through space or through solvent. Otherwise, it's just like inductive effect, but it's not due to polarization of bond. Then inductomeric effect. This one is as a result of influence of a negative charged ion or a positively charged ion. It is this ion that will induce the charges in the molecule. This is what we call inductomeric. It's not inductive effect per se, but it operates as inductive effect. And it's as a result of ion in the proximity of the molecule. Are we following, please?
Yes, sir.
So that is inductive effect for you. Now talk about the applications. One of the applications is the effect on bond lengths. And the stronger the inductive effect, the shorter the bond. If you have a strong inductive effect, the bond between that molecule will be shorter. Okay? Then we talk about dipole moments. In the case of dipole moment, the stronger the inductive effect, the larger the dipole moment. Okay? If you have an atom that constitutes strong inductive effect, it will have a large dipole moment. As you can see in this example, we know that chlorine is more electronegative than any of these other two atoms. So the bond in chlorine, we have will effect stronger inductive effect, and it has the highest dipole moment. Okay. Then we talk about the strength of acid as another application. Okay. The import of the strength of acid is that if you have an electronegative in an acid, if you have electron withdrawing species, okay, electron withdrawing species that will constitute negative inductive effect, it will increase the acidity of that molecule. Okay, negative inductive effect increases acidity. Positive inductive effect decreases acidity. Okay?
Sir?
Negative inductive effect increases acidity, whereas positive inductive effect decreases acidity. Okay? Another point you need to know is that if you have a negative inductive effect, the distance of that electronegative atom, or let me say, the further, you know what I mean by further? The further the electronegative atom to the carboxylic group, okay, the weaker the acid. Do you get this point, please? Are you following me?
Sir, please come again.
I said the closer the electronegative atom is to the carboxylic. This is the carboxylic acid group. Okay, the closer the electronegative atom to it, the stronger the acid. Okay, and the far away the electronegative atom, the weaker the acid. Do you get that point? We know that the stronger the electronegative atom, the stronger the inductive effect, the stronger the acid. The weaker the inductive effect, the weaker the acid. Another point is that the closer the electronegative atom to the carboxylic functional group, the stronger the acid. The far away the electronegative atom, the weaker the acid. Is that understood?
Yes, sir.
Then we talk about the strength of bases. How inductive effect affects bases. If you have electron donating group or atom, it will increase the basis strength. Okay, electron donating group increase the strength of bases. In other words, positive inductive effect increases basicity. Consequently, negative inductive effect will decrease the strength of bases. Do you get my point? And as I explained earlier, it is because of steric effect that trimethylamine has a weak, it's a weaker base than dimethylamine.
Sir?
It is because of steric effect that is trimethylamine is weaker than dimethylamine. Okay? Then another factor that affects electron availability is electromeric effect. Okay? Electromeric effect, this is an intramolecular movement of electrons. As you can see here, the movement of electron from the pi bond to this atom here is what we call electromeric effect. This one now becomes positively charged, while this one becomes negatively charged. The negative charge of this is not showing because hydrogen has attached to it. That's why the negative charge has been cancelled. Okay, that is electromeric effect. Now, electromeric effect also can be positive or negative. It is positive if the electron moves to the carbon atom to which the attacking reagent is attached. Like in this case, this is the attacking reagent. It's attached to this carbon atom where the electron moves to. This is what we call positive electromeric effect. In the case of negative electromeric effect, the reverse is the case. Okay, the electron moves to another atom other than the one in which the attacking reagent is attached to. In that case, we have negative electromeric effect. Okay? Are you following, please?
Yes, sir.
Then you have the application of the electromeric effect. This electromeric effect operates in addition reaction to alkenes. Addition reaction to alkenes. You know that alkenes generally undergo addition reaction. And in such addition reaction, the pi bond in the alkene is broken. Okay, that means the electron moved to another atom. So electromeric effect make this possible. And one of the reactions is the reaction of an alkene with bromine, addition reaction to alkene. Addition of hydrogen halides, electrophilic addition reaction, as well as electrophilic substitution reaction of benzenoids. All these are made possible by electromeric effect. Another application of electromeric effect is the addition to carbonyl functional group. Okay, as you have in this case, addition to this is a carbonyl. Carbon oxygen is what we call carbonyl functional group. So when you have addition reaction to this species, it's also made possible by electromeric effect. Like in this reaction, you have hydrogen cyanide reacting with propanone. This is propanone to give you this cyanohydrin as the final product. This reaction is made possible because of the operation of electromeric effect. Okay? Then, if you compare electromeric effect and inductive effect, you can see the similarity and their differences. Whereas in inductive effect, there's a bond polarization. Okay, there's a bond polarization in inductive effect. But in electromeric effect, there's no bond polarization, but movement of electron from pi to a particular atom. Okay? Inductive effect is a permanent effect, but electromeric effect is a temporary effect. If the attacking reagent is removed, the molecule will revert back to its original position. Inductive effect does not need the presence of any reagent, whereas before electromeric effect can take place, you need an electrophilic reagent to initiate the movement of the electrons. Okay? In inductive effect, you have partial charges, delta plus, delta minus. But in electromeric effect, there's no partial charge but full charges. That's the differences between inductive effect and electromeric effect. Can we go ahead?
Yes, sir.
Yes, sir.
Okay. Then you have resonance, or what we call mesomeric effect. Resonance or mesomeric effect. Okay. The difference, or what makes resonance or mesomeric effect unique is that, one, it involves pi electrons. Okay. It involves pi electrons. That is one. Secondly, that's what you call the localization. The localization of pi electron. This is what makes resonance or mesomeric unique. That is when you have the localization of pi electron. That in which case you can draw canonical structure for a particular molecule. Okay. Now, resonance can also be negative or positive. You have negative mesomeric or resonance if the substituent withdraw electron by delocalization. Then you have negative mesomeric or resonance. And groups that can withdraw electron from such molecule include nitro, carbonyl, and so on. Then you can also have positive mesomeric or resonance. Okay, that's when you have a group donating electron towards the molecule. They release electrons to the molecule by delocalization. Okay, an example of such group include hydroxyl, alkoxy, thiol, and so on and so forth. Okay. And these diagrams illustrate what we mean by negative in resonance or mesomeric. You see, here you have a carbonyl functional group, which is withdrawing electron from this. Now, the movement of electron is now delocalized. You can see that in this molecule, you have a pi bond. That pi bond is broken and transferred to this position. Okay. Now, when this negative come back to form double bond, this pi bond will also go back to its original position, like what you have here. So it's a reversible. This is a canonical structure for this molecule. So this one, because it is taking away electron from this, it is termed negative mesomeric. The same thing applies to each one of these. Okay. Then positive is when you have a group donating electron to the group, to the molecule. Like you have here, this is hydroxy attached to the benzene ring. You can see the oxygen in the hydroxy has 2 lone pair of electrons. One of the lone pair is transferred to the ring. And there's movement of electron around the ring like that to stabilize, okay, this new, you can see the bubble and goes like that. These are canonical structures that are stabilized by resonance. Okay, so this one constitutes positive resonance or positive inductive effect. Now there is this point here that resonance, wherever you have a resonance and inductive effect operating, resonance would always take precedence over inductive effect. It has more power. It will overshadow inductive effect. Okay. Application of resonance effect or mesomeric effect. One is the stability of carbocation. Carbocation is a carbon atom that has positive charge. That's why we call it carbocation. So the resonance of mesomeric stabilizes carbocation as it is depicted in this diagram. Okay. Then you have also stability of carbanion. Carbanion is a carbon atom that has negative charge. We call it carbanion. Okay, so stability of carbanion can also be explained by resonance or mesomeric. Then you have stability of free radical. I'm sure we know what we mean by free radical, where you have carbon atom with just 1 electron instead of 2 pair of electron. If you just have 1 electron, it is radical. Radical can also be stabilized by resonance or by mesomeric effect. Now, we have been talking about mesomeric resonance interchangeably. They have similarity and they have differences. Mesomeric effect arises due to the substituent functional groups in a chemical compound. Due to functional group. Resonance, where you have 2 or more structures that can be written for a particular molecule, but none of the structure can explain all the properties of the molecule. This is known as resonance. Mesomeric is permanent. Okay, but depend on substituent of the functional group. Resonance is also a permanent effect, but it has to do with the localization of pi electron in particular. Okay? Now, all the group that exhibit positive resonance effect will also exhibit positive mesomeric effect, and vice versa. Groups that also constitute negative resonance effect will also operate negative mesomeric effect. Is there any question so far? Any questions so far? Shall we go ahead then? Shall we go ahead? Then another effect is hyperconjugation. This one has to do with sigma bond, okay, but on alkene. You know, we said that alkene are non-polar. But in this case, if you have an alkene in the proximity of a radical or carbocation, you have empty p orbital in that species. Now, the localization of the sigma electron into that p orbital is what we refer to as hyperconjugation. Okay, that is hyperconjugation. So hyperconjugation can only be found in alkyl groups. Okay. It involves the localization of sigma electrons belonging to the carbon hydrogen bond of the alkyl group attached to an atom with an unshared p orbital. And hyperconjugation helps explain the stability of alkyl radicals. Okay, it helps explain the stability of alkyl radicals. And the example given here is that of a carbocation. That the more the hyperconjugative hydrogen, the more is the stability. In this case here, you have a tertiary carbocation. And generally, tertiary carbocation is the most stable carbocation. It is more stable than secondary carbocation, which in turn more stable than primary carbocation, which in turn more stable than methyl carbocation. Okay. Then we talk about steric effect or steric hindrance. Steric effects, these has nothing to do with bond. No, but it has to do with what you call overcrowd. When you have an overcrowding in the molecule, then you expect steric effect to operate. Like in this case here, you look at these two examples here, methanol and tertiary butyl alcohol, or tertiary butanol, if you like. You can see that this carbon is surrounded by hydrogen and hydroxyl, but this carbon is surrounded by methyl groups and hydroxyl. Okay, you can see that this carbon and hydroxyl is free, whereas this one is crowded because of the methyl group. This is what we call steric. This will constitute steric effect and ultimately steric hindrance. Okay, because of the overcrowding of the methyl group, it will affect the reactivity of this molecule. And that factor is what we call steric effect. You can also see another example here, this ammonia, as you have it here. Ammonia and trimethylamine. Okay, consider that in ammonia you have 3 hydrogen atoms, but in trimethylamine you have 3 methyl groups. These 3 methyl groups is what prevents the lone pair of electron from forming bond with proton. Okay, And that is why trimethylamine is a weaker base. It's even weaker than ammonia itself. Okay? So in any molecule, you have what we can describe as overcrowding. You expect steric effect to operate. And these are the factors that we discuss that affect availability of electrons. What comes next is just the summary of what we have been discussing all along. Do you have any question now? Any question, please? Any question again, please? Yes. Munira, we are finished. So, we are not. Mercy.
Yes, sir.
Can you unmute your microphone now? I ask question if you have any.
No question from my end.
No question.
From me, sir.
What about other people? Johnny, Rafiat. I think you are only appearing for the first time. I can't see your face, so let's all see your face. I think and Oladejo, these are new faces. On your camera, let me see your face.
Good afternoon, sir.
Good afternoon.
Yes,
you are coming for the first time. Right?
Sir?
You are attending for the first time.
Yes, sir.
Well, I don't think I've seen you in class before. What about
No, sir.
Oluwabusayo? Adegbite? Is she around at all? I don't think so. So, Oladejo, how far with the lecture? Oluwadamola. Oladejo, any issue with the lecture?
No, sir.
Okay.
Yes, sir.
Adegbite, Oluwabusayo, you are not responding. If there are no questions on so far, can we close for today then?
Yes, sir.
Okay, sir.
Now.
Okay, sir.
I want to say something.
What? This Adegbite, is she actually participating or just put something on and go away?
Excuse me, sir. I have something to say. He shared to us yesterday. And
I can't hear you.
I said the resolutions of the meeting that you sent to us yesterday that you shared with us.
Yes.
There was only provision for 2 weeks physical class. So, and then it's practical in this. How do we go about it?
Yes, probably we are going to use the 2 weeks for practical. in chemistry 235. Because practical is part of the component of this course. So what will happen is that we would have discussed the practical before you resume, so that when you resume, you go to the lab straight and carry out experiments. Okay?
Yes, sir.
Yes, I'm listening. Yes. Yes, I'm listening. Yes, yes. Go ahead.
Yes, I'm not seeing my assignment. I'm not seeing.
I've sent it to your email now.
Yes, I concern your assignment.
I've sent it to your email.
Where, sir?
I sent to everybody's email.
But my own is not. My own is not good.
Well, that is all. I mean, the problem from your end. Your email is not correct, or it's no more. It's no more. Google said it doesn't recognize your email. So unless you supply another email or you correct the error in your email, that's what you can do.
Okay. I'll send it to you on this.
What?
I said I will send it to you on this.
Okay. Now, I mentioned at the beginning that I'm preparing some questions for you. In the next coming day, there will be some questions you have to answer online. Okay, online. When the questions are ready, I will let you know. The question is going to be multiple choice. Okay, multiple choice. And there will be time limit for you to answer the question. Is that understood?
Okay.
So,
okay, sir.
Do you have any other question? Any other question? Can we end the class? You can call it a day.
Yes.
So, when next are we meeting?
Friday.
Okay, we shall see. We shall see then.
Yeah.